Hello, everyone. My name is Greg Schultz. I'm head of marketing at Instantiations, and I wanted to welcome you to our first event of this type. It's our technology preview for our cross-platform OS process framework, and this is coming to our VAST Platform 2021 release that's coming at the end of this year. We're really excited about it, and we're really excited to show you what we got coming up. And so let's get started. So. Who is this event for? I mean, you guys are here, so you're obviously interested, but just to make it clear, because we might have folks from various backgrounds, we want everyone to feel welcome. You know, we're going to try to keep the explanation slides a little bit higher level so everybody can understand it, but we'll delve into some technical details here and there when needed. And we do want to say that the live demos are more geared towards technical teams, so some VA small talk knowledge would be useful for that. But you can still kind of understand what's happening, even if you're not a hardcore developer. And then we encourage everyone to stick around for the Q&A at the end. So if you see something during the course of the presentation, you know, feel free to ask questions about what you saw and get some clarity and that kind of thing. So just to kind of give some more insight into what this event format will be like, all audience microphones are muted, and we'll first be kind of, you know, when we start off here, we'll be giving an introduction of what OS process frameworks are generally. You know, what do they mean in the broader context of computer science and things like that. But and then we'll give some background of the project itself, this new OS process framework. And then we'll talk about the available features that the new framework has, as well as how does this new framework function. You know, we'll have some good diagrams to kind of show that. And then we'll get kind of hands-on with some live demos, so you can really, you know, see it in action working as it stands right now. After that, we'll go into a Q&A session, and you can ask questions via the chat window. You should be able to like expand your control panel in your interface, and you should see a chat window there. When you ask a question, it will go to me, the host, and I will then push that on to Seth Berman, who will be presenting as well as, you know, fielding questions at the end. As a reminder, this event is being recorded, and it will be released on Instantiation's YouTube channel afterwards. So if you have to run out early or you can't stay for the whole thing, don't worry, you can still see the whole thing afterwards. Another note is if you're having audio trouble during the presentation, there are telephone audio call-in numbers. So if you are having trouble with that, please feel free to jump into that alternate way to get audio. Now, without further delay, I want to hand it off to Seth Berman, President and CEO of Instantiations, and he'll be kind of taking you through the initial presentation as well as the tech demos, and then we'll do the Q&A together at the end. So with that, I'm going to hand it off to Seth, and there'll be a little bit of a visual transition here.
Well, thank you, Greg, for that introduction, and just give me a few seconds here to share my screen and presentation, and possibly myself. Let me get to. Here we go. As I said, I hope everyone's doing well today. Thank you for showing up, and yeah, I really want to thank you for coming. We really appreciate you making the time to come learn about this really cool feature that's coming to VAST 2021. Before we get to the main event, I just kind of want to give you a quick company update, especially in light of everything that's going on this year. You know, in short, everything's going really well for Instantiations. As we anticipated when we sent out our COVID-19 plan in March, our support channel and development activities have continued normally without interruption. And if necessary, you know, we can operate the way that we are for as long as we need. You know, Instantiations has a long history of working as a virtual team. We do have a physical office here in Raleigh, North Carolina. So of course, the team here in Raleigh is missing each other's company. But other than that, you know, we've got really good tools, and it's sort of business as usual from our end. Outside of that, Instantiations is moving development forward at a very rapid pace. I think most customers of ours have recognized that. And for example, we just released VAST 9.2.2 in June. We did a 9.2.1 release this year, as well as a very large 9.2 release that introduced our new JIT compilers. We're still on schedule for a VAST 2021 release in Q4 this year. And I'd just like to draw your attention to our VAST Community Hub. It's a great way to get involved. This is up on GitHub. VA Smalltalk has some great new tools for integration with Git. Some of our customers are now involved with that. And it's a great way to get involved with community. So I urge you to check it out. And with that, we'll just kind of get on to the main presentation. So we're going to talk about OS process frameworks. And there's really two parts to this. The first part is the primary focus of today, and that's going to be about spawning processes from a given programming language. There's another half of this that deals more with systems programming. We're going to show both, but the primary focus will be on the former, which is spawning processes. But before we talk specifically about what we've done, let's talk about OS process frameworks in general. So what is it? Well, an OS process framework allows a computer language to launch a program, interact with it, communicate with it. This is all done programmatically through code. And every language, at least every one that I've seen, has some ability to do this. Maybe there's not a formal framework, maybe it's a series of operating system function calls, but basically every language has the ability to spawn a new program from itself. So sort of graphically, what we're talking about here is some main application has some sort of process, a module or function to it that's able to start a program, spawn it into memory as a process at that point. That program runs till it's either completed normally or either abnormally terminated. But in all cases, we have some sort of exit code, which becomes available to the main application. This is the basic pieces of what we're going to be talking about today. Different languages are going to have a lot of different capabilities surrounding this, but this is basically how the OS process framework, or at least this half of it, works. So a little bit about project background. We're going to cover kind of the current state of VA Smalltalk. Sort of as we looked at this, what are the required features? We're going to talk about our design and implementation challenges specifically, and the approach that we took. So before we even talk about current state, I'd just like to point out the whole, why are we doing this? So instantiations is primarily driven by customer demand. So we're always looking back and looking at, incoming support cases, requests, and trying to assess where the best direction is. And so this was something that has come up for a number of years. And so we knew that we wanted to address it, but we really wanted to do it right. So let's talk about the current state of OS process features in VAST. So currently VAST has the ability to do this as limited options for operating system interactions with regards to this type of framework. On the Unix and Linux side of the house, the support is much, much stronger. There's actually a formal Unix process framework with a set of abstractions and a way to do a lot of what we're going to talk about, though it's limited abilities. And it's very specifically tied to Unix, which is the reason that we don't have a Windows process framework counterpart. Now on Windows, we can of course launch programs, but we can't really communicate with them. We can't get their exit code. Really, the only thing is sort of a fire and forget. We can kind of see if it successfully launched or not, but that's really the end of the story. Now, beyond the sort of missing pieces of functionality, the problem here is the usage of kind of different APIs for each OS. And kind of the point is you want something that's unified in Smalltalk so you can work with a single set of abstractions, and the Smalltalk system itself will handle the OS specific details. So, limited options exist for communication and configuration for this type of work. You can do a lot, of course. I mean, our customers have been doing a lot with it for years, but it's not as robust or efficient as we want, and certainly taking into account the feedback that we've seen, we set out to kind of solve all that. And that's, of course, why we're here today. So looking at required features, first and foremost, we want a unified framework. Okay, it needs to be cross-platform. and it needs to be efficient. We want more communication options with the native processes, as well as better lifecycle handling. That means we want to be notified when these spawned processes complete. And we'll see later that's what the engine behind our new futures framework. We want better debugging and traceability behind what happened when a process was spawned. More security surrounding the Windows command line. You know, there's a well-known set of command line injection attacks. We wanted to reduce those, and so we have a whole sort of sanitization module in the VM that takes the command line and arguments, ensures things are properly quoted, ensures things are properly escaped, such that well-known command line injection attacks aren't feasible. Finally, the framework is Unicode aware. I'll talk a little bit more about what that means and why. But first, some design and implementation challenges. So the first part here is creation of an easy-to-use abstracted layer that implements these very low-level system tasks. So every operating system is very, very different in this regard. Sure, every operating system, at least to date, that I've seen has the concept of a process. But beyond that, working with them, getting the required information or notifications, they're all different, very different, and often very messy code to deal with. We wanted to maintain very consistent cross-platform behavior. We didn't want APIs where you make a call on Windows and the comments say, on Windows it will act like this, and on Unix it will act like this. We wanted very consistent cross-platform behavior for all the APIs. And that's a big challenge. We also enforced a zero OS specific code policy in VAS. So what we wanted in the VA Smalltalk code, which lives very low down, I mean, even below our platform interface layer, is a set of easy to use and understand abstractions. And we wanted to leave it at that. We did not want to litter up the Smalltalk code with a bunch of messy OS specific code. And we do have, so that's down in the VM. In the process, a new process module we created. Now that process module is very highly organized and has been refactored to the point where if we needed to introduce a new platform, we could do so fairly easily. But all those messy details are down there. Now, I mentioned we have tracing and some debugging capability. So for some of that, you know, when you push things down lower, of course, you get a little more opaqueness to what's going on. So we wanted to be sure, you know, we have tracing so you can get the information that you need. So how do we approach this? So, you know, OS process frameworks weren't invented yesterday or even last year. They've been around for a really long time. And that's good. That's good for us in this case. So we want, you know, so we needed to do ample upfront research to really understand, you know, where everybody's at with this. So of course that includes Smalltalk dialects, but also every other language out there. You know, out of morbid curiosity, we even looked at Fortran just GCC Fortran just to see. You know, inspiration was primarily pulled from Smalltalk and Java, Scala, systems programming languages like Go, Rust, and Swift. We looked at Dart and the libuv project backing Node.js and Python, of course. And from that, you know, we accumulated and implemented kind of the lessons learned from their issue tracking systems. You know, as I said, a lot of these frameworks have been in there for a long time, and users have commented on the various decisions that were made for those various frameworks. And so we did a lot of work and kind of perusing of forums to understand where the pain points were, just to make sure that when we launched this thing, we did not repeat well-known mistakes. So with that, we're going to talk specifically about the VAS 2021 OS process framework. First, a little bit about the available features. So of course, as we hinted, it's going to be fully cross-platform. Right now, that's Windows and Linux, but it's well prepped for any future platforms we do. It runs on the Intel, you know, 3264-bit, as well as our new ARM 32 and 64-bit, which we recently have is fully JIT compiled. We've been running them out on AWS Graviton processors, and so this is available for all of them. Communication between VAS and a process is highly customizable. We have, and I'll discuss more about it, pipelining and pipeline chaining, allowing for a conditionality in flows of information. Launching a process, pipelining, chaining pipelines with correct sequencing are all supported in Smalltalk. And those concepts are all implemented in pure Smalltalk with a combination of our process implementation and our futures framework. We have new traceability to see all the details behind program spawning. OS event notification drives a futures framework for life cycle handling. I discussed a little bit about security, and then it's Unicode aware, which means how we implemented this was we did what's called the Unicode sandwich approach, which means we take all the information from the outside, in this case that's command line, arguments, environmental variables, and we convert them to UTF-8 as quickly as possible and store it internally as that. Then once the framework makes operating system calls, they will be converted to whatever is needed. For example, on Windows, we use the wide APIs, so that UTF-8 is converted to UTF-16, and then it's converted back. And back in VAST, which is still driven by code pages, it'll basically convert to the code page. If you have a situation where your current code page can't handle a specific file that may have a certain Unicode character, you can always pass through as byte arrays that are in UTF-8, and it will know that that can just act as a pass-through, and it doesn't need to do any conversion. So how does our new OS process framework function? So we're going to go back and kind of look pictorially at this. It's a slightly more detailed version of that first slide. So we have the VAST platform. We have the process starter, which is kind of the builder object and configuration object for processes. That will start the program, which is then launched, but we also have separate communication channels, which can be set up, inbound and outbound. So the source and sinks for these inbound and outbounds can be a number of places. For example, for outbound, you can discard the output by sending it to the null bucket. You can send it to pipe streams that are connected to the VAST platform, which allows communication with the developer. You can also send it to files, and you can have those files in append mode. Now, as just I talked about consistency, so here's an area where we made sure things were consistent. When we do file appends on Unix, those are atomic. Well, on Windows, they're not, so we implemented special support such that we get true atomic appends when we're outputting to a file, so you don't get strange interleaving. So after that program exits, you can either terminate it programmatically, through some other means, it exits normally. We get an exit code, which notifies the VA Smalltalk. And as I said, that drives our futures platform, or futures feature. We also have pipelines. For those who use shells and are familiar with shells, it's going to look a lot like that, except they're object abstractions at this point, a little nicer to work with. We do have a DSL that surrounds both pipelines and chaining, so they're really easy to set up. But essentially, we have a pipeline starter where you run the pipeline, and it's basically a pipeline is a series of programs wired together such that the output of one flows into the input of the next, and the output of that flows into the input of the subsequent one. And you get, basically the point here is you get a lot of concurrency that's available. And so the nice thing is, a pipeline object is highly polymorphic with respect to a process object, and the same is true for pipeline chains. So they have pretty much the same interface. They all have input streams and output streams. You can kill them. You can, get a future on them and get notified when they're complete. The next is pipeline chaining, which is really just a variation on pipelining. Essentially, it introduces a logic gate so that you can send data flows in different directions. So in this example, we have a pipeline 1, which completes, and it arrives at a logic gate. And based on what happens and how the logic is evaluated, we may either go to pipeline 2 or go to pipeline 3. If we go to pipeline 2, then it will arrive at another logic gate, which may run a program or another pipeline. So they can all be kind of mixed and matched together. So the input of this whole construct is the input to program 1, and the output will be the output of either program 10, program 11, or program 7. It will have an exit code, which will make its way back to VAST. You can also get a future on this as well and get notified when it's complete. So with that, we'll get to the demos. Go ahead and minimize this. I have VA Smalltalk up and running. I've got a series of examples here we'll look at. And then, like I said, at the end, we'll have I'll show you the whole other half of this framework. So what you're primarily seeing here is just one half of the story. But you'll get a good sense, and it's still in development. So I actually have more examples since we began, planning for this. So first, we're gonna launch a process here that just echoes hello instantiations to the output. It's usually not going to be this verbose. I just wanted to show a lot of the commands that are available. So of course, here's the way that you can do you send the command with its arguments. You can we'll talk about being detached versus not. You can set the current environment, certainly the current working directory. Engine is sort of an advanced feature, but we'll talk about what an engine is. You just have tracing, yes or no, and there's a whole series of redirect and inheriting. You can inherit the standard out from VAST. You can redirect it to a file. You can, as I talked about, there's even options to redirect the error to wherever the output's going, so you can kind of merge them together. So let me go ahead and I'll just start this process. Go ahead and execute it. You can wait now. You can wait for the completion. So the important point here is this process, once you start it, is running asynchronously to VA Smalltalk. It's got its own life cycle. It's using its own processors, processor times. And so here we can wait, if we want to wait for its completion, we can do so. There's also another option to do something like that, where you can say, well, I want to wait up to a second. This is in milliseconds. I want to wait up to a second, and if it's not done yet, I'd like to just continue forward. So I'm pretty sure it's done by this point. It's probably done when we just executed it. I'll go ahead and show just a quick inspector on it, just so you can see that you get information to certain things, but we'll see more about it in other ways. So let's go ahead. What we can do is say, get me the output stream of the process. So for those that know, that's standard out. That's what it writes to. We're basically just going to say, hey, give me everything that it wrote to standard out. And as we would hope, since it echoed hello instantiations, we would hope we would get hello instantiations, and that's exactly what we get. Now, things will typically be much less code than that. Here, I'm going to use Notepad as an example for a lot of these. It's simple. I want to focus more on the actual APIs, and it stays running. So I need something that kind of stays running until I don't want it to anymore. So I'll go ahead and just start Notepad here. Okay, we'll just kind of keep it off to the side here. So now Notepad is a process that was spawned from VA Smalltalk, and so it has this OS VAST SubProcess class associated with it, and we'll see how there's some others later on. So one of the first things, we have a little bit of control to do, termination. So we can say process terminate, which will terminate the process programmatically. You saw that Notepad went away. We also have kill. Now on Windows, these are aliases of each other. On Unix, the terminate would be a sig term, while the kill would be a sig kill. We won't do so much, working directories, sure, that's supported. And like I said, that includes Unicode characters if needed. The environment, the only thing I want to show here is that when you set environment, and let's say it was empty, the process module is aware of the fact that there are just certain environmental variables, especially on Windows, that just kind of have to be there. And if they're not there, then weird things are going to happen. And so let me just show you like some of what those would be. So here I say I want an empty environment. So it says, okay, well, but you need to have this, at least these, or else you're going to get really strange errors and you're not going to be able to explain them, and things are going to go horribly. So we make sure that certain things that need to be there are there. Detached. So you kind of saw what that was. So the life cycle of everything that you spawn in VA Smalltalk is tied to VA Smalltalk by default. So for example, if I launch Notepad here, there it is, and now I close VA Smalltalk, Notepad also will go away. And so, but if you don't want that to be the case, if you want to detach it and have it have its sort of its own life cycle associated with it, then you just detached true. And now when I close VA Smalltalk, Notepad continues on with its own life cycle. And this is terribly, this is one of those things where it's a cross-platform to make that consistent behavior can be challenging when you're doing this across multiple, the concept of being detached across multiple operating systems. Let's have a look at pipelines now. Like I said, there's a certain DSL associated that should be familiar to everybody who's used shells with pipelines and chaining. In this case, I've got it's a small example where on my desktop, there's just this small file that has a few lines. Basically, the first command I want to do is the find command. I want to find every line that has item in it. So that's just going to be those 4 lines. So it should kind of filter out those 4. And then I'm going to pipe that into, or send the output of that into the input of the sort command. And so that's going to be a separate process that runs that will basically sort the output. So Z should be, at the bottom and A should be at the top, that kind of deal. So let me go ahead and create these new process starters. And then the way you create a pipeline is pretty simple. You just use this pipe command here, and we'll execute. And now what we have is a OS pipeline starter. Okay, and there's our 2 process starters right there. And now what we can do is say, start, and we'll just go ahead and wait for completion. And then I'll go ahead and check what is your output. And so what I should see, it implements put some header in there for some reason, but you can see that the output has been sorted. And this was an example of a pipelined type of activity. Now, obviously in practice, you can, these are a lot more powerful. What I'm showing you are the primitives for workflows that can be really powerful and get a lot of concurrency going. Another one is pipeline chaining. We're going to look at 3 basic operators: the sequencing operator, the AND operator, and the OR operator, which again, with these, at least with these first 2, you should be familiar from shell usage if you've done that. So what we'll do is a launch notepad here. Well, I'll create a notepad process starter. And now I'm going to connect 2 of them. I'm going to connect it with a sequence operator. So this basically says, I want you to launch Notepad, and once that's done, launch it again. And so this is different from a pipeline, because in pipelines, everything that's connected will be running at the same time. This is a sequence that says, first you run this, then this, and you can have as many as you need, and they can be connected to other pipelines and everything like that. So let's go ahead and start this. So what should happen here is that when I execute, 1 pops up, and now when I close this, another one should pop up. Let me see here, and there's the second one. Okay, so that's a sequence. Okay, so that's how you can get, do this, then that. The next one we have is the AND operator. And so for this one, the logic is going to be that, let's go ahead and start here. So when I close this, what I should expect to see is that another one pops up. So it's got to be, if this is successful, then do this one. If this is not successful, and by the way, you get to define what success is. It's either by default it's 0 exit code, but you can define a custom exit code or even a block of Smalltalk code to define what does success even mean. So here I'm going to close it, and I would expect another one to pop back up. Now let's do this again, but this time I'll kill it in a way that's sort of abnormal. So here this one pops up, that's this first one. In fact, let's look at the chain. We see here that we've got a left-hand side. We don't have a right-hand side yet. And so let's go ahead and kill it. I'll kill it with the task manager. Let's do that. So we'll go to details here, go down to Notepad. Notepad right there. We'll go ahead and kill it in task. So this is an abnormal termination. And so that went away, but no Notepad replaced it. That's because of the logic. Okay, that was a failure. And so it doesn't bother to do what's over there. And now if I update this, we see the terminal node has been updated. Okay, and so that's a way for you to see, conclusively at the end, what was the last process that actually ran. Okay, so we also have the OR conditional. And so in this case, we have, if this is successful, sort of short circuiting, this is successful, then you don't need to do the second one. Okay, so if I close this, then you won't see the second one. If we do it again, and this time what I'll do is I'll just look into the chain here a little bit to the left-hand side, and I'll go ahead and send the left-hand side the message, that process terminate. Okay, now we saw the second one pop up, and that's because that failed. So then it went and said, or let's do this one then. So that's what these conditional flows are about. And as I said, you get to define what success means in this regard. Okay, so on to our futures framework. So futures plays a big role in the implementation of these pipeline and pipeline chains. So what these are is it's an object that, for those that don't know, it's an object that basically acts as, you know, a placeholder for a future value. And then once that value is available, it'll be injected into that future, and you have the ability to have an action run or check if it's done yet, or just wait until, excuse me, wait until there is a value. And so let's go ahead and launch, or we'll create a starter here and launch Notepad. Okay, and then we'll get a future on it. So you say process on completion. We're getting a completion future. Okay, so what we're going to do here is sort of an asynchronous workflow. We're going to send the future on value due, and we want to execute this block of code whenever it finishes. Okay, and it's going to inject the exit value in the process itself. And what we choose to do is basically print the process ID and exit code to the transcript over here. So I'll go ahead and execute this. What happens? Nothing. Why? Because there's no value yet. We haven't, Notepad is still running. So let me go ahead and close Notepad. And once I close it, you can go look over here and you'll see that action take effect. So there's the actual transcript. That's when the action actually ran. There's also a blocking mechanism here. So if we do this again, here it's running. We're going to print to the transcript the process ID and exit code, but notice the way we get the exit code is by asking the future for the value. Well, there is no, excuse me, there is no value yet. And so we've got to wait until there is one. And so it's going to block. Now I'm doing this from the UI process, so it's going to actually block the UI. You don't have to do it this way. You can do it from a background process and it will just block that particular process. But just to show, I mean, so now my UI is all blocked up. In fact, the UI events are just sitting there waiting. So I'll drag it to the left and drag it down, and you'll see once it actually kicks back on, you'll see my window move here. So it's just sitting there on value waiting. So let's go ahead and close this. Okay, and you saw my window move around. Those UI events were able to come through again. And then there's the process ID and exit code. Okay, and then briefly, you can always ask if a future has a value. You can just say, hey, do you have a value yet? No, okay, I'll go do something else. So we don't need to run that. That's just another way to see if it's done. Here's an interactive process. So what we'll have at launch is we'll have some more, and this is what we're working on now because pretty much the engine is done. We're going to have more convenience APIs for doing things like tuning for interactive versus non-interactive. So in this case, interactive, we're going to be kind of talking back and forth with Python. We're going to launch Python. We're going to have it launch a little teeny server here, an evaluation server. We're going to redirect all the I/O to pipe streams that we can communicate back and forth with. I'm going to go ahead and merge the error with the output, and then we'll start the server. Now, what the server does is it sits there waiting for input, and once it gets some input, it evaluates that input as a Python expression, and that will return a result, which we then print to standard out. And then this is wrapped in a while true, so it goes back and starts waiting for input again. So there's the Python process right here, and we're going to ask for the input stream, which is the other end of this, and we're going to send it 1 + 2 + 3. Okay, so one would hope that as it just received that, it evaluated it, hopefully that became 6, and it printed that back to the standard out. So now we're on the other end of standard out here, and we're going to say, okay, get me the next line, convert it to a number, and bring up an inspector on that. And there you go. And you can just keep, the point here is it's interactive, so you just keep, you just keep doing this over and over, communicating with whatever the process is. Finally, when you're done, of course, we can terminate the process. Just a little bit about engines. So this is more an advanced feature, but we implement quite a few engines. On Windows, there's just one engine, the create process. On Unix, there's fork exec, vfork, POSIX spawn, which is our default. We also have a kind of a more hidden engine because that old Unix process framework is being deprecated. So we created an engine that sort of mimics it in the meantime. And so Unix process will redirect to our new framework. So you can select the engine that you want to use. I don't think most folks probably won't do this, but it's there and it's available. For tracing, basically I said there's a tracing module so that you can see what things were like when they spawned. I'll just go ahead and inspect. So basically the process starter, I'll say tracing enabled is true. Let's go ahead and start to that. I'm just going to do a dir listing command. So then it will kind of spit out, and this is going to get more and more information as we go get to the final release. But for right now, we're kind of printing out the information as things occurred. Get to see some times and things like that. Okay, now we're starting to kind of bleed into the more systems programming aspect, but they're all the abstractions kind of work together. There's not a lot of abstractions to deal with. We've got basically we've got an OS native process, which is more of the ephemeral sort of processes out there you can always query and ask for. We've got a OS vast process, which is a special class for representing just the vast process. And then we have OS vast subprocesses, which are basically everything that you spawn in VA. So here we're going to start Notepad again. And now let's ask for its info and get some information about it. So we can see things like its command line. This is going to be the resident set size. On Windows, this is like the working set. It's going to be in Linux like the resident set. This is the maximum amount of memory that's used. So resident set size, this is the memory in RAM, so not really virtual memory. You get a start time, total amount of CPU duration. So this is not duration total. This is the amount of CPU that actually used, as well as the user for the given process. Okay. And so another way, so of course we can also get this in another way. So this is going to have because we started it from vast, it's going to have an actual vast subprocess class here. Okay, so OS vast subprocess. So it always knows what process, and then it knows if it kind of keeps track of where it came from. So let's go ahead and kill that. But now what I'll do is I'll launch one from my Windows menu. So now I launched this externally. I did not launch this from VA Smalltalk. So now when I actually go and query OS processes all, get me all processes, detect the process P such that the command matches notepad.exe, what I should get now is an OS native process. Okay, so this is this is a little different in that regard, but you can still do pretty much everything you can do with the vast subprocess, except that it doesn't have kind of stream connections to it or some other things, but you can get information on it. You can get futures on it for when it's completed. You can other kind of controls, like you can kill the process, like we'll do that right now. So this was not started from vast, but I can go ahead and control it. Now, the reason I can kill it is I did start it from my user, so I have the appropriate permissions to do that. If we look at OS processes all, and now we'll start to bleed into really the really cool stuff with this type of framework, I can say OS processes all, and that will get me all processes running on the system. Right now, about 284. You'll see as I kind of scroll down here, there's going to be certain processes where we get more information than others, and that's because that's based on the permissions that the VA Smalltalk process that I'm running this from has. Okay, so we can also always get the current vast process. Okay, and that has OS vast process class, and it's got some of its own specialized behavior. We can always get what was spawned by VA Smalltalk. We can also just query by PID and say, okay, for a process ID, for example, we're running as 4088. So then I can always query and say, get me, that process. And it does keep track and knows which class to assign it to. So it's the OS vast process. Here's another easy query. Get all processes that I own. Okay, so this is now just a select statement on all processes. And I say such that the user is my user, the user of vast. Okay, and that's going to be this set. So I've got about 113 that are running as the same user as the vast process. Okay, another one is of the processes that I own, get the one that is currently using the most memory, okay, and most memory in resident memory. Okay, so from this, it's going to be we're just going to sort it. I mean, there's probably other more efficient ways to do this, but we're just going to sort it and ask and basically get the highest current RSS size. So my biggest process, yeah, this happens sometimes. 1 second. Another important note is that, these really truly are running externally. I mean, all these processes. And so that means that at any point in time, so when you do something like this, at any point in time, one of them could die. So you always have to kind of check at some point, is it still alive? And we have facilities for doing that, but for a small amount of code, I did it this way. But you actually saw where one of the processes that I had previously cached had gone away, and so it couldn't answer info. It wasn't there. And so my largest one right now, it looks like the IntelliJ IDE. So let's just take, it's not surprising. So let me just take a look at the info, current RSS. Okay, so 1, 2, 3, 6, about 424 megabytes. And at some point it used a gigabyte worth of memory. No offense to IntelliJ, I'm sure it's caching lots and lots of stuff. So with, here's where I can collect up my processes that have children. Okay, so that's another thing. You can get relationships. Children, parent, get me all children, sort of children recursively. Get me my parent chain. So let me do this all the way from the top, just so if something died, it can handle it. So here's all my processes that themselves have children. Okay, so this one in particular, this was the Google file stream drive, had 3 children. Here. And so from these children, I can say, get me your parent. And so it should answer the 13952, which it does. And you can get, the parent chain all the way back to the top. And the big part about this is, for folks that have implemented this kind of stuff, this is, this is very operating specific, messy code. And so, but what we're showing you here is a bunch of, select and sorted and detect statements. This is all completely cross-platform. So here's another one, total memory used by my current processes. Okay, so this is just a select of, the same processes by user, and then I'm doing an inject where I just tally up the current RSS. Okay, so yeah, because I'm using VMware, so it's roughly 4.4 gigabytes or something. So I have another operating system running in the background. Total CPU time used by my current processes. So you can see how simple this is from Smalltalk code and cross-platform, but this is really powerful stuff that you're really querying here. So and as a final, I mean, this is something I just put up in about 20 minutes, and and most of it was figuring out, showing a table view, but I'll show you how simple the model is, and this is completely cross-platform. I'll show it that this is just a task manager clone. This is essentially, and it's refreshing every second. And basically, this is just task manager showing the name and the PID and the user and the creation time and CPU working set peak. It looks like Windows Task Manager, except it can even show children, parent-child relationships. And just the amount of code that this took was so small, and then it works on cross-platform. So here's the model, and of all these methods, 5 of them are all about starting and stopping a 1-second monitor. Okay, here's the code. Basically, here's the items that you pass to that table. Basically, you're saying, get me the vast user, get me all processes that match it. Of those, sort them. You can see here I'm handling the fact that maybe they died sometime during it, and then sort it by file name, a base file name, and then pass that back. And that's what goes into the table. And then at some point when I click the little triangle, the table might have called children, but it's already, the process object's already set up to do that. So let's take a look on Linux here. I'm just going to launch this on the Linux side, and from my other development environment, and let's go ahead and execute. Okay, so here, same code, same exact code. And like I said, for people that know, to get this information, on Unix is completely different. You're traversing the proc file system, grepping through bunches of stuff. On Windows, it's a bunch of, API calls and, it's totally different. But here, we're quite easily able to create this nice cross-platform experience with the same information. And so I think that that sort of wraps up what I wanted to show. I'm going to pass it back to Greg now, where we can do some Q&A if you have any questions. But I hope that you've enjoyed what you've seen here, and we're certainly excited about bringing this to our customers. Thank you.
Thank you, Seth. So to continue, now is our Q&A session. So please ask questions via the chat window. Those questions, again, will come to me, the host, and nobody else will see the questions you ask. So don't be shy about just asking questions if you're not sure what you saw, or things like that. If you can't find the chat window, there's a little red arrow at the top that expands and contracts your control panel, and that's where you can find it. So for the first question that we're going to answer here is the question is, can you pipe a small talk object, example an array, into a shell command, example a sort? Seth?
Can you pipe a Smalltalk object like an array into a shell command sort? I don't I don't know the answer to that. I don't think so. At least I've never tried it, and I'm not sure how that would reify down in terms of a shell. I'm going to guess no. Though that's an interesting, I'm kind of writing this down because that's an interesting concept, that sort of mixing between those worlds. So it's certainly something I'll take a look at. I have not tried anything like that. It does sound intriguing. So I will definitely look into that. And if we can get something like that in before VAST 2021, that might be really nice. So thank you for that question.
Great. Next question. Would it be reasonable for a VAST image to start other VAST images and communicate with this mechanism?
That's a good question, and yes, ultimately yes. In fact, I would say that there is a bit of this opens up the doors for a bit of orchestration, because you have the like the Python example I showed, where there was more of that interactivity, where you're able to talk back and forth. Now, certainly, you're able to launch other VA Smalltalk commands, and you can get messages or logical messages to them via arguments, via a custom environmental variable that way. But with these nice streams we have, you can also have actual communication via pipes.
Okay, great. Next question. Can you have 2 or more pipelines running in parallel?
Absolutely. As many as you need.
Okay. Next question. Is it possible to see the current CPU usage of a process with the new framework?
Yeah, excuse me, we looked briefly at that. And so there's really 2 things that was on the list. So there's 2 things on the list that we're still taking a look at if we can describe appropriately across all platforms and kind of all future platforms. I think CPU usage seems reasonable. So that's really a matter of kind of looking at how that would work across each system. And virtual memory was the other one, to sneak in virtual memory and see if that was a concept that will always work. So currently not yet, but I think that will probably be there, as my guess, when we launch this.
Okay, great. Thanks, Seth. Next question is, can processes be started as another user?
Not currently. There's some difficulties on Windows. It is something that I hope that we can do. I don't know if that'll be once we do a launch or something, but that was discussed internally within the team as something that might be nice to do. And so we'll look at that. But yes, I think that is a good idea. I certainly understand, especially with all the systems programming stuff we showed at the end. It would certainly be nice to run as an elevated user if you had the ability to do that.
Okay, next question. Is the script manager that you're using new?
No, it's not new. It is, let's see if I can, it is slightly, I slightly modified it just because it didn't have the ability to cache variables like the STS our main workspaces do. But this is available as part of the master NV developer script manager. And then I've got a version that caches the variables. So that, because I didn't want to be tearing these off during the presentation, I thought that was a little distracting.
Okay, and then we have another question. It's been framed as an add-on question, but I'm not exactly sure what question it was adding on to, but the question is, would it be easy to duplicate the running image with additional parameters, perhaps in addition to the server Smalltalk framework?
I'm just ingesting this question. 1 second. With additional. Yeah, I think that would be feasible to do. I do. And I'll have to give it a try. But I think that is a perfectly reasonable use case and it could be done. Good question.
Okay, and next question is, can you change the priority of a running process?
No, like the niceness values and that no, I think that might be a good feature. So yeah, it's really at this point it's a small matter of understanding across each platform how that works and making sure that it's something that all platforms would support. I think that's another example of something that sounds reasonable to do. That and sort of I was looking at CPU affinity as well, which I guess would be the Windows concept for that. So yeah, that's a good question. I think that that is feasible. You can't do that currently, but of course it's still in development, so current doesn't mean very much yet.
Okay, great. So before we get on to more questions, which we're happy to do, just as a time check, we are getting close to our time for the end of the event. We're about 5 minutes out, so we'll keep answering questions, and we want to be respectful to everybody's time. So just to let everybody know, we will keep answering questions as we receive them, and as long as we can kind of stand on here to answer them. So if you have to go though, please send an email to info@instantiations.com with your question, and we'll be happy to get back to you there too. So continuing, this is another kind of lengthy question here. This allows VAST to access the OS. Are there any plans to make VAST accessible from the OS, i.e., could you access a VAST global variable by name, for example, from outside of VAST?
I'm just taking a moment to read this again, just to make sure I understand. Well, you can't access a VAST global variable. I mean, if you find some way to export it, I'm sure. I mean, this isn't really under the purview of the OS process framework, but I think that you probably. Yeah, I'm not sure how to answer this, just because I'm not sure exactly what we mean. We can't export, something like a global variable to the OS, but I guess its value, you could find ways to do that. But it does. I mean, one point about this question is does touch on the fact that this framework does open the door to communication with other vast processes, as another question was saying, via environmental variables or arguments, things of that nature. So there is communication there, but I'm not sure quite using that any sort of exporting a variable mechanism.
Okay, and to the person who asked that question, if you'd like to reach out to us and discuss it more, feel free. We're certainly open to talking more and making sure that we're understanding the question correctly. Next question is, if I start Smalltalk from a Smalltalk, can I also read the stream/transcript from the started Smalltalk, of the started Smalltalk?
So you can read the the transcript is not the transcript like in Smalltalk, but there is a but the TTY transcript. So that's basically the standard out, standard in streams that every process has. That's sort of the gateway into a process. And so, VAST has connections to those standard out and standard in. And actually one of the tasks that we're looking at before we launch this is to make sure that those are easily accessible, because we imagine that is a big use case to be able to orchestrate and launch other VA Smalltalk images. So of course we want to make sure that, as if you launch another image, that image is able to like easily send things to SD, standard out and to read, from standard in. Otherwise, it's kind of missed some stuff there. So I think that leads to a really good point of how people would want to use this. And so, yeah, that's on the list to make sure, on the child side of the fence, on the spawn side of the fence, that a VA Smalltalk image would have, kind of like that Python example I showed. That was a pretty simple little evaluation server, but it had what it needed to read in something quickly, to write out something quickly, just to make sure that's accessible. So good question.
Okay, and the next question is, will it be possible to do a callback via entry point in the process into the calling image?
I don't know the answer to that off the top of my head, but I'm writing it down just because that's an interesting use case. So I'll just try it, and I'll get back to the asker of this question.
Okay, and next is, does this framework also launch managed code in a Windows environment?
So managed code. So this is going to excuse me. This is going to launch. You can launch, I don't know, like .NET instances and communicate with them the same way you would communicate with VAST, or other managed runtimes. Although I might be missing the mark on what the question's really asking. So it doesn't. I mean, so it launches processes, which that may have managed code running in it. It doesn't sort of have any integration with managed code beyond that. So I hope that kind of answers it. But you guys can always contact me if it doesn't. I'm happy to go back and forth and make sure it's answered.
Okay, next, will this be the easiest way to access C# functions? Example, a function that wraps an exiting C# functionality.
So this is kind of the same, probably in the same vein as the managed code. So this will allow you to, I think the better use case here is if you launched, at least for this framework. Otherwise, it's more bridging what we're talking about, I think, with this question. The OS process framework is about launching other processes and then communicating via streams to their standard out, standard in. So in this context, if you wanted to do something like that, it would be more of a launch a .NET server or client that then is sending information back and forth through the standard out and standard in connections to VAST, as opposed to actually running managed code then somehow interleaved with what's happening in Smalltalk. So that's, or some sort of FFI to a managed code, which is more of the bridging situation. So I would say that this is not that. This is more about, yeah, launching processes and then communication with them through their standard I/O streams, or standard I/O, yeah, capabilities.
Okay. And Seth, I sent you another question here. You can go ahead and take a look at it. It is a longer multi-part question. Yeah, go ahead.
So, is the futures framework implemented within VAST OS process, or is it in base VAST? Okay. So the right now the futures is in OS process. It's specific to OS process. However, the second order of business, because we think it's really nice now for use across the board, is but we want to smack on some slightly a little bit more interface to it to act like, to be as useful as it would need to be for a generic futures process. So I would say I would call it more the beginning to that story. And if we can get it in for VAST 2021, great. But I think it's going to serve as the basis. I mean, when we were kind of developing it, we didn't understand that it was going to be as nice as it ended up being and useful. So I think it will lead to that. Let's see, we've got, are there futures used in the VAST FFI framework? So I believe for asynchronous callouts, so that's the callouts where we call out using a operating system thread, a native operating system thread, and that calls C code or external code via that mechanism, and then there is some sort of futures associated with that. It's not really a general purpose futures. It's more about the fact that that is an asynchronous call, so it's got its kind of own life cycle, and so the futures is used as a way of managing that between what's going on in Smalltalk and what's going on in that native thread. But it's not a general purpose framework. Any chance of a donated port into Squeak supporting your open source friends? Like I said, a lot of this is in the VM down with the, I mean, there's a wealth of code that of course could be considered for lots of different folks. But then there is sort of a layer kind of in between, I would call the operating specific stuff, and then what's going on in VAST that is sort of specific to VAST's primitive calling mechanisms, asynchronous calling mechanisms. Async calls are used quite a lot just because of some of the, for example, for our streams, we have both, we have these really high performance buffered streams that can do both, that have the interfaces for both blocking and non-blocking calls, and they're organized in their categories according to that. And so in order to do blocking effectively, we use actual asynchronous callouts. So there is a bunch of code that expects the fact that there are going to be asynchronous callouts. Of course, there's a whole bunch of code that's just operating specific code, and there's code that's in the Smalltalk system. So, I mean, I'm always happy to collaborate. I don't know if the code itself is going to be, we're going to rip it out of the VM and put it, somewhere on GitHub or something. But if somebody wants to collaborate with us, that's fine. We're always open to that. I mean, we support open source. When we typically fund the VAST and help fund the VAST and ESUG conferences with our sponsorships, and there's a lot of ways in which we do support open source. But as far as our code, we do have stuff up in GitHub. But according to this, I would just reach out to me and let me know what you're thinking, and I can let you know what we can do. I mean, happy to help all of Smalltalk however we can. Sure. Can you chain futures is the last part of this question. Yes, you, oh wait, I'm sorry. Can you chain futures? Okay, I know what you're saying. Yes, you can chain futures. Now, like I said, I think there's a little more to do there such that you get the kind of futures frameworks you see some of, like I'm thinking about Dart right now, but there's some others where you got the nice, then do and then do, then do, and you have this long sequence of chains. Here you would emulate that with on value do, and then you have a block, and then you do another future in there, and then you say on value do, and then a block, and it's syntactically different at that point, but it does effectively the same thing. Like I said, I think a more general purpose one would be an order where we would want a little nicer, interface and do more of that chaining. Like I know what you're talking about. I've seen those examples. So that's a good question. So thank you for all those questions. Those were good.
Yeah, that was a very good multi-part question that was asked there. The next question is, can input streams and output streams be binary?
Yes, they can. You can put them in binary or textual mode, and they are so their other attributes are they're buffered or not buffered. Like I said, that tune for interactive, part of what it does is adjust that buffering or make sure that the if it is buffered, let's say that there is an auto flush, so that, because the last thing you want is to, say in that Python example where you write out 1 + 2 + 3 and just sits there in a buffer and like never makes it to Python. So yeah, well, part of our convenience APIs is to tune everything for specific use cases.
Okay. Next question is, since Unicode was discussed again today, when a process that has been started returns Unicode, will everything be converted to UTF-8, or will VAST-10 also support Unicode?
For VAST-10, we're planning some support for Unicode in terms of a Unicode support library. So if it returns it, it will be converted to UTF-8 internally. And so you can get it as a pass-through, as a byte array, where it just comes to you as a byte array as UTF-8, and you do what you will with it. If it needs to come back as a VAST string, then it was converted to the code page conversion. So your particular code page, whatever, however that might be represented, it will have that conversion done or not. So one of the things, though, that leads to is sort of a that we don't have, and we may, but I'm not sure yet, is that for, like, let's say output streams. So I think this is more towards your question. If you get a bunch of text and yeah, it's outputting, something, UTF-16 or whatever, or UTF-8, then there's no sort of it would be nice. I mean, you can always just connect that up to a code page converter and just do it yourself. But it would be nice if the streams themselves had some sort of transformer associated with them that you could optionally plug in a transformer that would handle the transformations. It's not there yet. That is not the highest priority of what we're doing, but I think if we can make it for 2021, that would be a nice little addition. So we'll certainly look at that.
Okay, next question. Is this new feature available in 32-bit as well as 64-bit?
Yes, it's available in both 32, 64. Yeah, and even that, I mean, that could be a challenge too. I'm trying to think about anecdotally how difficult it is to get the list of arguments for a given process in Windows. I mean, it's an incredibly complex set of code. I just couldn't believe it. I was totally floored. So, and that part is very sensitive to 32 or 64-bit, reading, because you're reading processes that may be 32 or 64-bit. So, and you're doing that from a 32 or 64-bit source. And so, it was incredible. It's an incredible amount of code to get the arguments of a process. I was astounded. But like I said, I mean, consistency was a goal. So while on Unix, it was like, oh, this is how you do it, and this is really easy. And then we got to Windows, and I thought, I just can't believe what I'm about to have to do here. But we did it, and it works. So yeah, 32 and 64-bit, we frequently test. We're running about 110 S-unit tests right now that do some pretty exhaustive stuff. We got much more to go. And so I think that, and we're always testing on 32, 64-bit. Like I said, ARM 32 and 64-bit is part of that story, which is a bigger deal now with what's going out on AWS and the data centers. You know, ARM running on ARM out there, and like Graviton and stuff, is going to drive costs down for our customers. And we now have more and more customers running in the cloud, so it works there as well.
Okay, the next question is, orchestration is a good subject. Will there be an API so that two Smalltalk images can communicate with each other at process level? A kind of callback in your already started Smalltalk process?
Not as part of this initial effort. I expect that we'll get some, kind of like what we're getting right now, a lot of great feedback regarding how people want to use this. Because it's not, what we're seeking to do here is build the primitives for, for all to lay the groundwork for all this. I mean, there's a lot of these questions. I mean, they're really great, and so I'd love to get all of these in. I just don't know if it could fit. I mean, especially we're about to start our Unicode effort as well, and that's going to take us to the rest of release. So, I think these are going to be the next iteration type of things, especially as we see how people want to use these. And just like I was talking about, where we went and looked at everybody else's pain points, we're obviously going to have some of our own that we tried to minimize them. And so as we capture those, we'll take the iteration of version 2 and try to address them.
Okay, the next question is an interesting one. It says, is VAST specific to a single Smalltalk VA or available, installable in Squeak and Pharaoh? And Seth, I can help with this question if you'd like, but
yeah, go
free.
ahead, take a shot.
Well, I would say in general, VAST is an abbreviation for VA Smalltalk. We've been kind of using that abbreviation for years. And recently we've been discussing, VAST as more of a platform than just, VA Smalltalk. So when we refer to VAST or VA Smalltalk or the VAST platform, they're all essentially the same thing. So I hope that answers the question. Next, let me send this over to you, Seth. Can one send signals, such as SIG user 1 to launch processes?
No, not currently. And this is the kind of thing where we start to get into the differences between operating systems, and if they can be really represented as signals, for example, is very, very specific to one operating system and not so much another. And so, if it's not, we have to draw UI frameworks that try to solve this cross-platform, situation, run into the same issues where, of course you want to try to represent everything for everybody, but at the end of the day, you're kind of stuck at, trying to represent the lowest common denominator and trying to fill in the gaps where you can, which we've done a lot of that. I've already talked about some of it, but signaling and specifically, I mean, that to really understand how to do that in, say, Windows, for example, what kind of APIs can we use, and without having to start to get into API leakage, which I've seen before, where you start to add APIs just because you can, and then it doesn't really make sense because the comment now says, well, this is on Unix, this will do this. On Windows, it's a no-op. I mean, we don't really want to go down that path, at least yet, until we really are, customers are screaming for something specifically. But yeah, that's where I would stand on that.
Okay, great. So it looks like that is the conclusion of our questions that we have here. I really want to thank everybody for asking questions and giving comments through the question chat, functionality. It was great to hear your feedback and get all these questions. And I really hope that as you heard the answers to these questions, it maybe answered some more questions you didn't even know you had. So with that, we'll kind of wind this event down. I wanted to remind everybody that ECAP, our Early Customer Access Program, is something that we do for every launch, and stay tuned in the coming months. I think a couple months maybe, where we're releasing our first ECAP for VAST Platform 2021. So you've gotten to see a small part of VAST 2021 today, In a couple months, you'll probably be able to see much more of the platform and use it yourself. So with that, I wanted to thank everybody for attending. And if you have any more questions or you think about a question after the fact, please email us at info@instantiations.com. And keep up with us on Twitter and LinkedIn and our website too. And again, thank you so much for everyone coming today. And it was great hosting you all.